Before you watch this video, you should first try to prove this theorem on your own. If a quadrilateral is a parallelogram, then the diagonals bisect each other. You're given parallelogram ABCD. Notice I've already marked that this is a parallelogram with the given information. I've also marked something that I know about a parallelogram. What do you know about a parallelogram? What's the definition of a parallelogram tell you? Well, the definition says both pair of opposite sides are parallel. So notice I've identified that segment AB is parallel to DC and that segment AD is parallel to segment BC, and then I've marked them parallel, two different sets. Now if I have parallel lines, notice here I have transversal, which is a diagonal here, and I have a second transversal, which is another diagonal. But if these are parallel and this is a transversal, I'm going to be able to get alternate interior angles are congruent. I could even possibly get two pair of alternate interior angles congruent, or I could use vertical angles. So there's not just one way to do this proof. But what I'm going to do next, and I'm going to mark that angle ABD, that's an alternate interior angle, is congruent to angle CDB. Now I could have marked the other pair, but I'm not going to. I'm going to do it a different way. Those are congruent because if two parallel lines are cut by a transversal, then alternate interior angles are congruent. That's what the alternate interior angle theorem says. Next, I'm going to notice I always have to have a side to prove that triangles are congruent. I see 4 triangles in here. I'm going to try to prove these two triangles are congruent. Well, I know the opposite sides of a parallelogram are congruent. So I'm going to mark this side congruent to this one, because right now I'm going to just try to work with these two triangles now. So opposite sides of a parallelogram are congruent. I want you to notice I have an angle and I have a side. I have an angle and a side. I need more information. What other information can I get from that picture or that diagram? And I know why it's true. Like, are there other angles that I know that are congruent? There are. Angle AEB is congruent to angle CED. Those are vertical angles. So I can mark those. I also could have marked the other pair of alternate interior angles, but I'm going to use the vertical angles. Having a little bit of a hard time marking those. See if I can do a little bit better than that. Now notice I have to do 2 arcs because that's the second set of angles. Okay. Now those are what type of angles? Vertical angles. So vertical angles are congruent. That's vertical angle congruence theorem. Now, those 2 triangles are now congruent because I have an angle, and that corresponds with that angle. I have this angle that corresponds with this one, and I have this side that corresponds with this one. Angle, angle, side. Angle, angle, side. So I can prove the triangles congruent by angle, angle, side congruence. Now it's very important how I name these triangles, because how I name them is how I'm saying the vertices match up and how corresponding sides and how corresponding angles match up. Triangle AEB. So A corresponds with C, CED. Now, if I change the name of the first one, I have to change the name of the second one so that corresponding parts are matching up. Now, if I've got congruent triangles, then I can match up some corresponding parts. Notice segment AE is congruent to segment CE. Notice they're in the same location there. So AE is congruent to CE. Also notice that DE is congruent to BE. Those are corresponding parts as well. So I'm going to mark AE congruent to CE. I also can mark these segments here congruent, but my picture's gotten a little bit busy. So it's going to be a little bit hard to mark that. Let's see if I can though. 1, 2, that's my third set of sides. segments by matching it. Now, why are those congruent? Corresponding parts of congruent triangles are congruent. That's what that CPCTC stands for. Now, since AE is congruent to CE, that means E is the midpoint. And since DE is congruent to BE, then E is the midpoint. By definition of midpoint. I probably could have done this proof without that step and went straight to the next one. AC and BD bisect each other because a definition of a segment bisector is a point line array that divides a segment into two congruent segments. Well, notice that this diagonal divides this diagonal into two congruent pieces, and then segment AC divides segment BD into two congruent pieces. So now we know that the diagonals of a parallelogram bisect each other.